All right, so special cases. Now remember, things won't actually be labeled like this when this stuff comes up. We're going to start 11. I mean, we don't know it's a special case when we start, so we start it just like everything else. What would be the first thing you would do? What would we do on 11 first? Distribute? Okay. Could we move the 8C? Yeah, but distribute is probably what most of us would do, so that's what I would do. So we're going to distribute the 5. All right. So I still write on the left, 1 plus 3C equals 5 minus 5C plus 8C. Then I would for sure suggest that before you move anything else that you actually combine like terms, so that we get 1 plus 3C equals 5 minus the 5 plus 3C. I'm sorry, my God. I should just stop. Now, we also talked last week that about half of us, our team, we move the variable first, and the other half of us, our team, we move the other one first. Does it really matter? No. Will this look a little different in the end if we do it differently? Yes. So I'm going to do it both ways because that was a question earlier. Me personally, I always move the variables first, probably just because that's how it was drilled in my brain. So I'm going to subtract 3C from both sides. That will leave me with 1 equals 5. Does 1 equal 5? No, we get a false statement. Now, if you would move the variable or the numbers first, and so the person that asked me this morning was like, I got a -4. All right, well here, if I just subtracted 5 from both sides, I get -4 plus 3C equals 3C. Well, then when you subtract 3C from both sides, you get -4 equals 0. Does that true? No. So we both of us would have gotten false statements. They're different false statements, but they're false statements. So what's my answer? No solution, exactly. And then somebody asked me, what makes this a special case? Well, it's because we don't get x equals 5 or something like that. It's because we're getting a false statement. You have to know that it means no solution. That's what makes it a special case. It doesn't happen nearly as much as you actually getting a number like x equals 5 or something. Okay. All right, so then let's look at 12. So I'm going to start by distributing that -8. So I'm going to get 40 minus 8x equals -8x plus 40. So again, depending on which way you would do it, I would add the 8x to both sides first. So if I do that, I get 40 equals 40. If you subtract 40 from both sides, then you get, let's say, or you get -8x equals -8x. And at this point, this is a true statement, but it doesn't get me anywhere. Here, if I divide both sides by -8, I get x equals x. And then, you know, you could get 1 equals 1 in the end if you wanted to keep going. But either way, you're not getting an x equals 5 type of thing. But we have a true statement. So then what's my answer? All real numbers. Another way to say that, which you saying all real numbers, 100% fine. But if you see it written somewhere, it could also be referred to as infinitely, I gotta spell it right, infinitely many solutions. And that's what all real numbers is. But just wording wise, if it said that, that does mean the same thing. You wouldn't have to say it, but just so you know what this is fine too. Okay. Everybody good with all that? Any questions? Okay. So proportions, mainly want to do these just so that we make sure, again, we don't make the ridiculous mistakes that we are all capable of. So on 13, we are not cross-canceling like we were with fractions. That's where some confusion comes in. If that was not an equal sign, if that was a multiplication sign, then I could reduce the 2 and the 40, right? But I can't reduce the 2 and the 40 because we're not multiplying. I'm going to cross multiply, so I'm going to multiply 5 times x plus 4. But if you ever have anything that's more than one term, you need to put it in parentheses. I also highly, highly suggest that you just write it down and don't actually multiply. Even though it might be easy and you're very capable of it, that's where your careless mistakes happen. And then that's equal to, then I'm going to go this way, 2 times 40 right? And then it's just like any other problem we've done. I distribute my 5, get 5x plus 20, because that's usually what happens. If you don't write it out, you do 5 times x, and then you leave the 4, and that's wrong. Equals 80. So 5x equals 60. What does x equal? 12. Okay. Any questions about that? All right. Then you do the first step. Just like do the first step in 14 and stop because I want to talk about it. I'm going to write it maybe unlike what you might write. I'll tell you why. Okay. So if I model it exactly like 13, then I would do 10 times 2x minus 8 equals. Now, if you wrote yours differently than mine, it doesn't mean you're wrong. You don't have to erase. But if I'm going to do 10 times this, and then I'm going to go this way, then I would have 5x minus 9 times 8. Now, honestly, if I was just doing this problem, I probably would have written the 8 first, just because it makes more sense when we distribute to it, whatever. But I was just doing it exactly like I did the other one. Either way is okay. Like the top times the bottom here and the bottom times the top there. But either way, the distribution is the same. So if you put the 8 in the front, totally fine. We just have to make sure that we actually distribute. Okay? So you go ahead and finish this one up. Now I'm not completely done. I stopped there on purpose, so just make sure you at least get to that part. And going from this row to this row, I did 2 steps in one, which is fine. You don't always have to do every single little thing separate. I do a lot of times so I don't lose anybody, but that's not, I subtracted 20 from both sides and then I added 72. So that's how I ended up with that. Now when we get here, remember fraction-wise, I don't want a decimal. I need a reduced fraction. That's what you're going to be asked for the great majority of the time. You can look for the biggest number that divides into it, but honestly, it's easier, I think, to just think the fact that they're both even. So that's a -4/10. And then they're still both even. I get -2/5, and I can't go any farther. So, depending on how your brain works and what you can do with the numbers, it's fine to take a couple of steps there instead of trying to get a bigger one, okay? So, questions? All right, so now the literal equations, which you usually like the least, but they're honestly easier than everything we just did because we don't have to actually reduce fractions. We don't have to actually compute the numbers and stuff. It's the same steps that you've been doing forever. You just can't make it harder than it is. So on this one right here, I'm trying to solve for pi. So we just don't make up math, right? Here's pi. The 2 and the r are both being multiplied by it. So in order to get rid of it, we do the opposite, which is what? Divide. So I'm just going to divide both sides by 2 and r. You can do it separately if you want, but you don't have to. So on the right-hand side, the 2 and the r cancel out, and you're left with c over 2 times r equals pi. And when you do these, whether they are capital or lowercase, matter. What always matters, and in math, whenever you're writing stuff, you've got to write it capital or lowercase, however it is, because they mean different things. Okay? Are we good on that? Questions? All right. So look at 16. What's the first thing we'd like to do? Multiply by 2. Get rid of that fraction. Absolutely. So we're going to multiply both sides by 2. On this side, it cancels out. That's why we did it. So don't go doing extra stuff over there. So we have 2 times big A equals little a times little p. And we're trying to solve for little p. So we do what? Divide by little a, right? And if the capital and lowercase didn't matter, then I'd be able to cancel out a's, but you can't do that. They mean two different things. In this case, it's area and apophthegm. Okay. What questions we got? All right. Looking at 17, regardless of what we're trying to solve for, what do we want to get rid of first? The fraction. We always try to get rid of the fraction if we can, right? So I'm going to multiply both sides by c. On the left, they're going to cancel out. So I get a plus b equals 5 times c. Then do I divide by a? No, because that's addition and subtraction, right? So instead, I subtract a from both sides, and I get b equals 5c minus a. Any questions? Don't be afraid to ask a question just because nobody else is asking a question. We're all good? All right. Trying to solve for x. So just like anytime you're trying to solve for x, you're trying to get this term by itself. So we want to move this term first. I do that by doing what? Adding, right? So 3x equals 24 plus 3y. Then what do I do to get x by itself? Divide by 3, exactly. See, y'all know how to do this. I know you do. Those cancel out. So we get x equals. So can I actually simplify this fraction? Yes. What if this was 4y and not 3y? Then could I simplify that fraction? No. I could do the 24 divided by 3 and then leave it like 4y over 3, but I wouldn't even need to. But because I can, I have to make sure I can divide it into both, right? That's the key there. I don't get to just do the first one and move on. So 24 divided by 3 is 8, then plus y. Okay, so when you do that type of thing, make sure what you're doing is actually legal. That's where we get ourselves in trouble. We good? All right. Could I do start 19 by distributing the 1/2? Could I? Yes. Do I really want to? No. I think I'd rather get rid of it, right? So I'm going to multiply both sides by 2. This will be 14w equals, and then again, don't do something weird like try to distribute. The whole reason you did it was to cancel that out. So then that gives me w plus v. We are solving for v, so we do what with w? Subtract it. Very good. So we get 13w equals v. Everybody good with that? Any questions at all? All right. On 20, again, I could start by distributing the 180, and if I did, my answer might look a little bit different in the end, but I wouldn't be wrong. But I don't think I want to distribute it just to try and do something else with it because I'm trying to get in by itself. So we can start by dividing and get s over 180. And so when I divide both sides by 180, that cancels that out, leaves me with n minus 2. Then what do? Add the 2. So I get s over 180 plus 2 equals n. Does that become s plus 2 over 180? No, absolutely not. I'd have to get common denominator, but I don't need to, so I'm going to leave it like it is. Okay, are we good? Any questions at all? This is just basic solving equations, like we hadn't gotten anything too crazy. So if you're thinking this is easy, I'm hoping you're thinking that it's easy, but that doesn't mean it didn't knock some cobwebs off of things, right? We just want to make sure we don't make ridiculous mistakes.